Assalamualaikum. My name is Muhammad Hanan Razi bin Azman with matrix number of B0819100031. Today, me and my lab partner will be presenting about Faraday law. First of all, what is Faraday law? Faraday law stating that when a magnetic flux in a circuit is changed, the electromotive force, which is EMF, will induce in the circuit proportional to the rate of change of magnetic flux linkage. So, without further ado, let us go to the explanation for this lab.
Hello, Assalamualaikum. My name is Muhammad Nidal and my matrix number is B0819102221, and I'm here to explain about the first point is the deflection of meter during the movement of magnet bar. Alright, a wire coil is connected to a galvanometer. When you push a magnet towards the center of the coil, then pull it away, the galvanometer needles deflect in one direction, then the other. How far the needle deflects depends on the strength of the magnet and how fast you move it. This is an illustration of Faraday's law of induction, which states that a changing magnetic flux induces an electromotive force, or EMF, in a loop of wire. This EMF then pushes a current through the loop. Even though it is the induced EMF that is responsible for the current, it is not uncommon for people to speak of the current as being induced by the changing magnetic flux, as a kind of shorthand for a coil wound so that the turns are close to each other. The change in flux through each turn is same, and EMF appears across each turns. Alright, for the second point that I will explain is the difference on deflection of meter when change the magnet pole. Alright, as we can observe, the meter pointer will deflect toward the negative when the north pole of magnet bar is moved toward the coil. Meanwhile, the meter pointer will deflect to positive when the south pole of magnet bar is moved towards the coil. Likewise, when the magnet is moved away from the coil in the other direction, the needle of the galvanometer deflects in the opposite direction with regards to the first, indicating a change in polarity. Then, by moving magnet back and forth towards the coil, the needle of meter will deflect left or right, positive or negative, relative to the directional motion of the magnet.
So now we in the last part of the observation about the brightness of the bulb when the number of turns of the solenoid is different.
So here, as you can see, the above solenoid has lesser number of turns of solenoid. So now, when the magnet bar is entering the solenoid, we can see that the result from the above solenoid when the magnet is present is the bulb brightness is dimmer compared to the magnet bar moving in the below solenoid. This is due to the different number of turns of solenoid. Why is the number of turns of the solenoid will give us the different result? This is because from the Faraday law equation shown beside, it is stated that the number of solenoid turns manipulate the EMF, hence the brightness of the bulb also. This is because the number of solenoid turns is directly proportional to the induced voltage. As for a conclusion, the magnetic flux in the circuit will change if there is a magnetic substance is placed in the flux linkage. This will induce an EMF. The second and the last one is the pull and the movement of the object that move in the linkage will give different observation at the output, such as bulb brightness and the pointer meter.